Hey guys, I'll be doing warm-up 8 today, and hopefully you get something out of it. So 101 asks us to find the greatest common factor of 24 and 42. So you can break this down into 24 into 4, 4 and 6, and then 2 and 2. And 42 breaks down into 7 and 6. Notice that this is the only factor shared, 6. 7, 2, and 2, 7 and 4 don't share anything, as you can see by 2 and 2. So if 6 is the greatest common factor, we need to find the LCM of that and 15. So that would just be 30. Because 15 doesn't work, so you go up to the next multiple, 30, and that works. 102. So a circle P has a diameter CD. So let me draw this. So circle P, that means the center is P. It has a diameter CD. DC. And then it says that point B is on the circle such that BPC is 30 degrees. So it's about here. B. And it also says AD runs parallel through to it. And when something is parallel, you draw this little chevron thing to indicate that. And that means those are parallel. So if it says AD is parallel to PB, the degree measure of arc ABC. What's this degree measure? Well, since this is parallel, we know that this is also 30 degrees because this line is stable. It's like a transversal. It cuts the two lines that you could extend. And this comes here. It's also 30 degrees. So arc ABC, by the inscribed angle theorem that we learned, you multiply by 2 and you get 60 degrees. I'll do 103 over here. Points A, B, C, D, E are collinear. Let me draw them. So we have A over here. I'm going to put D over here first, and then it first tells us that B is the midpoint of segment AD, and AB is 6. 6. And then it tells us that D is 3/4 of the way from A to E. So this means we know this whole thing, AD equals 12. I'm going to draw a line here. AD equals 12, right? So if AB is 6, AD is 12. And that means AE, since this is 3/4 of 12, that means 3/4 of AE is 12. So 12 times 4/3 is equivalent to 16. So that means E, which would be somewhere here, AE equals 16. And we can subtract AB from AE to get BE, which is 10. 10. Then lastly, it tells us that C is 1/5 of the way from B to E. So I'll draw C about here. And that means this whole thing is 4/5 of 10. So CE equals 4/5 times 10, or 8. So 104. 104 asks us, what integer is closest to this thing? So 999 over 200 is approximately 5. 898 over 301 is approximately 3. Because 900 divided by 300, 1000 divided by 200. 797 over 402, is it? Yes. Is approximately 2, because 800 divided by 400. And whatever the other thing is, 696 over 503, if you round, it's approximately 1. So also these things are a little bit less than 5, a little bit less than 3, a little bit less than 2. This is more than 1. So when you add these together, you get that the sum, I wrote a weird sum equals 11. And that's your answer. 105. So it asks us what's the value of 1,000 squared. Over 252 squared minus 248 squared. We can use the a squared minus b squared thing, identity, on the bottom, and we get that 1,000 squared is 252 plus 248 times 252 minus 248. This is just 1,000 squared, or 1,000 times 1,000, I'll write it, divided by 500 times 4. This over here is 2. So we get 2 times 1,000 over 4, which is just 500. And that's your answer. Mental math is key in math counts. I'll try to fit one more here. 106. This figure, so here there's a rectangle inscribed in a circle, but that actually doesn't matter. So the rectangle has integer sides and integer diagonal lengths. And it asks what's the smallest possible area of the rectangle. Essentially what it's asking is, I'm going to draw the rectangle a little differently. Rectangle, and you have a diagonal. Both of these, this diagonal and the sides are integers. So essentially, you have a right triangle with integer side lengths. These are called Pythagorean triples because you have a, b, c, such that a squared plus b squared equals c squared is true, for a, b, and c are integers. The smallest Pythagorean triple is 3, 4, 5, the 3, 4, 5 right triangle, because 3 squared plus 4 squared is 5 squared. So when you do that, you get that you get 3, 4, 5 right triangle. So if 3 and 4 are the sides of the rectangle, that means the area of it is just 12. And that's your answer. I'll erase it. This is becoming a really bad paper towel. 107. So it tells us on March 1st, Kenny and Linny had jars containing the same number of pennies. I'll call that P. So they had P pennies. And then 1 month later, Kenny has 2 more than 3 times his original number. So Kenny has 2 more than 3P. Kenny. And the other person, Linny, has 7 fewer than 4 times her original number. Linny, 4P minus 7. So, it tells us then that that Linny has now 8 more pennies than Kenny does. So that means 4P minus 7 is 8 more than 2 plus 3P. And you can break this down into an algebraic equation. 4P minus 7 equals 10 plus 3P. And you solve, subtracting 3P, add 7. You get P is equal to 17. And that's how many pennies they originally had. 108. So train departs DC at 8:15 and arrives at New York City at 12:05. So we want to figure out how many minutes that was. From 8:15 to 8:15, 9:15, 10:15, 11:15, 12:15. That's 4 hours. So 9:15 is 1, 10:15 is 2, 11:15 is 3, 12:15 is 4. But we want to know to 12:05. So it would be 4 hours minus 10 minutes. 4H minus 10 min. 4 hours is just 240 minutes, because 4 hours times 60 minutes per hour. So 240 minutes minus 10 minutes equals 230 minutes. 109. So it gives us an algebraic thing. It tells us that x squared y cubed to the fourth times x to the fourth y to the fifth all raised to the sixth is equal to x to the a, y to the b. And we want to know a plus b. So we can use exponent rules to break this down. So exponents distribute like this. And you multiply this exponent into that exponent. So here you'll get x to the 8th, y to the 12th, times x to the 24th, y to the 30th. And then when you multiply exponents like this, you add them. 8 plus 24, 12 plus 30. So you'd get x to the 32 and y to the 42. You'd add these numbers to find a plus b, because 32 would be a and 42 would be b, and you get a sum of 74. 110. So here it asks us what's the value of this long thing. It's 1, 1, 1, 1 minus 2, 2, 2, a bunch of things. You can take a look at it on your paper. But what I'm going to do is I'm going to rearrange it so that I have this 1, 1, 1 thing over here. I put all the positive terms here. And then 5, 5, 5, 5, and then 77. So I have those positive terms here minus these negative terms. 2, 2, 2, 2, 2, 2, 2 here. And then we'd have 4, 4, 4, 4, 4, 6, 6, 6, and 8. And we'd add these together. This, you can add, this here gives you 1 plus 5, 9, 6. And you'd carry the 1 to the second column. You get 6 plus 1, 7. And you'd carry the 1 again. In this column, you get 9 plus 1, 10, 0, carry the 1. 9 plus 1, 10, 0, carry the 1. 5, 4, 1, 1. So you get 11,450,076 for this first part. And then, for the second part, you'd add these. So you get 2 plus 4, 6, 6 plus 6, 12, plus 8, 0, 20. Carry the 2, 2 plus 2 plus 4 plus 6. And that would give you 14. Carry the 1. Same thing here, 14 plus 1, 15. Or not 14 plus 1. This would be, that's my bad. 2 plus 4 plus 6, that would be 12. Plus 1, 13. Carry the 1. 1 plus 2 plus 4, 7. 6, 2, 2. So here you get 2,267,340. And then you just subtract these. And when you subtract these, you'd get a 6 on the edge. 7 minus 4, 3. 0 minus 3, you'd have to take 1 from the next, but then you'd have to borrow from the next one. So 5, you'd get a 4 here, 4 here, and you'd get a 9 here, because you'd have to borrow again here. So you'd get 10 minus 3, 7, and you'd get 9 minus 7, 2. 4 minus 6, you'd have to borrow again. 3 minus 4, or this becomes 3, this becomes 14. 14 minus 6, 8. This is 3. 3 minus 2 is just 1. Then you'd have 1 minus 2. You can take this 1 and borrow it here and make it 11 minus 2. And then you get 9. So your answer would be 9,182 736. And that's your answer. If I was confusing, you can do it by yourself, and hopefully you should understand this. So, hopefully you got something out of this video, and have a nice day.